Sec 5 NA Revision Homework Sheet 1. Now in this part of today's lesson, we are going to revise a little about set language and notation, but we're going to involve some other concepts. For example, the inequality conditions on the different sets itself, and understanding how to find the number of elements in each set, okay, and to how to understand union, intersection, and we'll do a little bit of shading, and as well as we're going to over a tiny little bit on probability. Alright, as for matrices itself, today we're going to learn the meaning of a matrix square. This actually means taking the matrix times the matrix itself, not squaring the individual terms. And on top of that, you'll be also studying about how to form and solve simultaneous equations using matrices. And last but not least, we'll do a quick revision on vectors. Alright, without further ado, we shall begin with our lesson. Question number 1. Given that the universal set is such that x is an integer between 6 to 15 and is inclusive of 6 and 15, so now what usually we do is we interpret by writing down the list of numbers that your universe have: 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Okay, and set A is such that x is a multiple of 3. Now we must follow with the numbers from the universal set only. So in this case, we will have 6, 9, 12, 15. Okay, that means multiple such that it's 3 or more than 15 is not included in this universal set. Next one, part B, set B. X is an integer such that you have the inequality over here. Now it's difficult to understand such an inequality, but first we have half x to be more than 4 less than 7. So what we're going to do, we're going to find x. That means we'll multiply both sides by 2, and that will become 8 and 14. So x is the number between 8 and 14. So set B will be the set such that it's between more than 8. So we start with 9, 10, 11, 12, 13, but less than 14. So we're going to stop here. Okay, so now we have all the elements of set A and set B ready. The question asks us to find the elements such that is between A intersect B. That means it's common between set A and set B. Therefore, A intersect B will be, what are terms that are common between these two sets? And we have 9 and 12. Next one, part B. Question asks us to find the number of elements that's inside A complement union B. So that means I need to find out what is A complement first, isn't it? So what is inside A? You know what is not inside A but inside the universe. So numbers that are not inside A but inside the universe, the A complement will be 7, 8, 10, 11, 12, not 12, 13, 14. And now we take this set to union B. So A complement union B will have, now the elements that are the same do not repeat themselves. Okay, we'll write them only once. 9, like 10 is common, but we only write once. 11 also, 12, 13, and 14. Okay, so this is set A union B complement. Now the questions ask for n number of elements. So how many do we counted? 3, 4, 5, 6, 7, 8. There are 8 of them. So n for A complement union B, number of elements in this set is 8. A number y is chosen at random from the universal set. Let's check how many numbers are there in the universal set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 numbers in the universal set. So I'll need a denominator to have 10. Find the probability that y is an element of A union B complement. To do this, we must first find what is A union B first, right? And then the complement of it. So A union B gives me the set 6, 9, 10, 11, 12, 13, 15, where we merge A and B together into one set. Then A union B complement, that will give me the numbers that are not inside are 7, 8, 9, 10, 11, 12, 13, 14. Okay, so these are the three of them. So in this case, the probability of choosing such a number will be the answer 3 out of 10. Have you gotten the answer? Question number 2, shade the set A intersect B complement. A intersect B complement. So although I know the answer directly, but I'm going to do a little bit of working first. If I want A intersect B complement, I'll need to shade it in 2 different directions. And then I erase away and leave the answers, the portion that has the part where it's overlapped. Okay, so I shall shade A first in one particular direction. Set A. Intersect B complement. B complement means everything outside B. So outside of B, outside of the set B. Okay, ignore whatever that A is. We just focus on the set that is outside, okay, of B. Then look at the portion. Where is the portion with 2 lines? We have 2 different shading. So in this case, this one only have 1 line, so I don't want this portion. This one also 1 line, I don't want this portion. And then, oh, here cannot touch, here have 2 lines. That means they only want this section. So shade the section in the Venn diagram below with A intersect B complement. This will be your answer. Okay, in set B now, question B, find the set notation that represents this shaded area. Wow, this is quite easy to see, isn't it? This is inside of A, so I need to include A. And then I want it also the portion outside B. So there is either I'm looking for intersection or it's a union. But since it's not going to be intersection because nothing overlaps, so this will be union B complement. Inside of A, outside of B. And I want the both of them, so union. Right, have you gotten the answer? Next question. A toy manufacturer produces toy cars and planes. The following table shows the breakdown cost of manufacturing for each toy. So now this matrix A, take a look at the matrix A. What does this mean? This means that the rows actually means car and plane. The columns actually means labor, number of hours, wood, number of blocks, and paint bottles. Okay, and they tell me that labor costs $8 per hour, wood costs $1 per block, and paint costs $2 per bottle. So this is actually the column is given by dollars, money. Alright, so they ask us to evaluate what is the matrix for C. Okay, so C in this case will be the taking back matrix A multiply by matrix B, 8, 1, 2. And we know that the row here is car and plane, and this is talking about money. So in our final answer, we should have 2 by 1 column. 2 row 1 column, where this is car and plane, then this is the money. So we're going to take row by column, row multiply by column. So 5 multiply with 8 plus 4 times 1 plus 2 times 2 gives me $48. And then the second row, we have 3 times 8 plus 6 times 1 plus 4 times 2. And that gives me $38. So now question A part 2. This is A part 1. A part 2 asks us to explain what the numbers in the answers represent. So the numbers over here, the rows represent the car and column, and the dollar sign represents what? This is the cost, right, of making each of them. So making each of the toy, car, and plane. So what does the number in your answers represent? It represents the cost of manufacturing toy, car, and plane respectively. Let us move on to part B. Now part B asks us to do this matrix multiplication, D to C. So let's take a look at what is matrix D. D is given to be 150 and 300. And I need to multiply it to C, which is actually cars and planes. And then the money. So if I were to multiply them, these two matrices together, in order for it to make sense, 150 must match with 48. That means this will be the quantity for the number of cars. And then we need 300 to match with 38. That means this will be the quantity for the planes. So if you were to multiply them together, this will be the total cost of manufacturing all the different number of toys, toy car and toy planes. Alright, so I will have one row and then one column. So that means I'm going to add up everything. That will be a total amount. No respectively. So that will be 150 times 48 plus 300 times 38. And that gives us 18,600. Okay, and this is talking about money. So explain what does your answer represent. It actually represents the total cost in manufacturing all the toy cars and planes, right? So this will be the answer. Have you gotten the answer? Let's continue with the next question. Question number 4, matrix multiplication. Now in this part of the question, there's something worthy to take note of. We purposely chose this question for you to practice on what is a matrix square. So if you have a matrix square, it's actually B times B itself. So in this case, find the matrix P and Q such that P is equals to B square minus 2A. B square minus 2A is actually B times B. So P is equals to the matrix B multiplied to the matrix B again, subtract 2A. Alright, now one of the common mistakes that students will do is they will try to square every single element. But that is definitely not true. Okay, this is a 2 by 2 matrix, and multiplied to a 2 by 2 matrix, in the end we'll get a 2 by 2 matrix. Alright, but the multiplication works as a normal matrix multiplication. So 0 times 0 plus negative 1 times 3. And we'll get the answer to be negative 3. Then we take the next one over here, 0 times negative 1. Negative 1 times 4, and add them together and we'll get the number negative 4, followed by next step 3 times 0 plus 4 times 3. 3 times 0 is 0, 4 times 3, 12. And then last but not least, 3 times negative 1 minus 3 plus 4 times 4, 16. Negative 3 plus 16, that will give me positive 13. Okay, and then we subtract with this. I'm going to multiply the 2 inside. So it becomes minus 4, minus 2, 4, and 12. Then we'll subtract and get the answer. And this is the answer. Okay, part 2 of the question. Now I crop the picture a little bit so that I can see my matrices. Now find the matrix Q such that A times Q equals to B. Now be warned that there is no matrix division in this case, only multiplying by a scalar multiple. But since A is actually a matrix itself, so what we need to do is we need to perform matrix multiplication Since I do not know what is Q, I'll let Q be the matrix A, B, C, D. Now, how do I know that Q is actually a 2 by 2 matrix, not some other size? Because I need to multiply A to Q, row by column. Notice that there's 2 columns over here for A, so that means Q will naturally have 2 rows. Okay, and for our final answer, that's column 1, column 2 to be equals to B, right? So since there's 2 columns, that means not only just 2 rows, the final answer for Q here also must have column 1, column 2. Which means there will be 4 digits A, B, C, D, and A is given by the matrix -2, -1, 2, 6 to be equals to B 0, -1, 3, 4. Let's now begin with our matrix multiplication. We have row 1, column 1, and then column 2. So now this is -2 times A, -2A, plus -1 times C, that will give me minus C. Okay, and we have -2 times B, -2B, plus -1 times D, so minus D. Okay, and then we have next one over here, 2 times A plus 6 times C. So 2 times A plus 6C. And then the other one will be 2 times B plus 6 times D. 2B plus 6D. Now this is equals to 0, -1, 3, and 4. From here we can see 4 equations. So it's actually quite a lot. Alright, so 4 equations. Let us do them slowly by slowly, one by one. I see on the first column itself, I have a -2A minus C to be equals to the number 0. And then I got 2A plus 6C, row 2, column 1, to be equals to the number 3. So equation 1, equation 2. Now we notice that both of these two, they are of the same number over here. This is 2A and that is also 2A. So what we can do is we're going to do addition so that it will disappear. Right? So 6 minus -6 minus C will give me 5C left. 3 plus 0 will be 3. So C will be 3 over 5. So now after I found C, I'm going to find A. So 2A plus 6 times C is equals to the number 3. 2A plus, okay, and then we solve the equation. This is what we'll be able to get. Alright, so I know the value for A and C now. So similarly, we're going to repeat a little bit for our the other 2 equations. So I know that equation number 1, -2B minus D is equals to the number -1. And 2B plus 6D is now equals to the number 4. Okay, so since this is equation 1, equation 2, since both the units here are the same and the sign is different, I'm going to do addition. So I get 5D to be equals to 3 again. Alright, and then D is equals to 3 over 5. So if I were to substitute similarly into this into my equation, 2B plus 6D, which is 3 over 5, equals to the number 4. I will have 2B plus 3.6 to be equals to 4, 2B equals to, and we find B. So this will be the answer for B. So now questions asking us to find A, B, C, D. We have found all the 4 answers. Have you gotten the concept? Now we'll have the last question for the day. In the diagram, P is a point on DC such that D to C is 2 times of DP. What is this trying to tell us? So D to C is actually 2 times. So D to P is and P to C will be equal in length. Okay, X is a point on BP such that 3bx equals to 2bp. Well, we don't like this, right? So we're going to change this to 3bx is equals to 2bp. I'm going to shift this down to be bx over bp to be 2 over 3. So bx is 2 units. bp is 3 units, so that means xp is 1 unit. Okay, and they all lie in the same straight line over here. So this is what we can conclude. Okay, let me erase this and shift it up. Okay, and I have the vector a to d is 4a. Okay, with the roller skates. A to b is 3b with the roller skates. D to P is 2A plus 3B. Just now we already know that P to C is the same, right? So 2A plus 3B as well. Okay, express as simply as possible in terms of vector A or vector B, the vector A to P. How to go from A to P? So I'll start traveling from, this is A part 1. I'll travel to get AP, I'll travel from A to the point D. And then from the point D to travel to P. A to D is 4A. D to P is 2A plus 3B. So I'll get a total of 6A plus 3B. Have you gotten the answer? Part 2. BP. How do I find B to P? Oh well, B to P, I can travel a long route or I can use a shortcut since I found AP already just now. So B to P is B to A and then A to P. So B to A is given by 3B. But B to A, I want B to A going in this direction. This one here is in the opposite direction. So I need to add a negative sign. And then I'll travel from A to P. Given in part A, we have found it. Hey, what do you notice? This is actually 6A. So let me write this down. I have 6A over here. This is 6A plus 3B. Where else do you see the vector with just A only? Now highlight, this one here is 4A. So if this is going to be 6A, what can you conclude about these two lines? Okay, we should know that they are really parallel to each other. But, okay, they didn't ask us, so I'll do that later. Next, they want us to find the vector AX. Okay, let me clean up my screen a little bit so that we can continue with the working. They want us to find A to X, so A to X will be A to B and B to X, right? So I know that BX here gives me, BX is 2/4 of BP. From here, BX equals to 2/3, of BP. So BX, so I want to find AX. AX will mean A travel to B. And then B travel to X. A to B is in which direction? A to B is in the correct direction, A to B. So it's 3B. B to X now is 2 out of 3, 2/3 of BP. BP, I got the vector just now in part B to be 6A. So simplifying this, I will have 3B plus 4A. Do you get the answer? Okay, so I should write this down. 3B plus 4A. This looks a little bit familiar, but I'm not very sure. Next, they want us to find A to C. Well, how to find A to C? A can travel to D, and then D will travel to C. So A to D is 4A given. D to C, oh, it's 2 times, right? 2A plus 2A, that will give me 4A. 3B plus 3B, that will be 6B. So in total, I have 8A plus 6B. Do you find this a little bit familiar? Look at it down here, 6b plus 8a. That means these two are actually a multiple of each other. They are parallel. So, okay, now answer the next part of our question. Next part of the question says, from your answers, okay, so part part 3 answer, ax is given to be 3b plus 4a. AC is 6b plus 8a. And we notice there's a multiple, right? 3 and 6, 4 and 8 is 2 times of 6. Wrong. 2 times of 3b plus 4a. So that means AC is 2 times of AX. And what deduction can you make about the points? Oh, AX and C. Okay, first of all, if this is true, AC is 2 times of AX, so AC is parallel to AX. Not only that, magnitude of AC is 2 times the magnitude of AX. Okay, that's number 1. Number 2, I know that there is a common point A. So since A is a common point, A, X, and C are collinear. They form one straight line. Have you gotten the answer? Now we come to the end of today's work, and we'll see you for the next session.